with this one. It is so silent that we cannot measure the noise, the low frequency noise. We have a law here in Denmark. We had a new legislation this new year that said we had to document, approve noise from 10 to 160 hertz in frequency, because the government said that we need to make sure that they're not making low frequency noises, because this can make people sick with nerves and stomach aches and lots of different things. So they made this for the big wind turbines, the big megawatt wind turbines, but they forgot that wind turbine is a wind turbine, no matter if it is a small 6 kilowatt or it's a 3 or 6 megawatt. So that was a problem for us. We needed to make a new noise measurement report, and the problem was we couldn't measure it because the background noises were bigger than what the machine was making. So we had to measure. The law is so that if you measure and you can't measure it, you have to go another day and do it again. If you can't measure anything that day, you have to go another day and measure again. And when we did this 4 times, we said, now our pockets are not deep enough for this. Because these 4 measurements have cost in total 100,000 crowns.
Wow.
So then I went to this department who's making the legislation about this, or making law about this, and said, we need some piece of paper from you that tells us that we have no low frequency noise on this machine.
Mm-hmm.
Because then we can go out and use this, of course, as a sales argument. We have a silent machine. And they said, well, you can't do that because the law says you have to document it. You have to prove the noise. So right now we have a noise report showing how much the wind turbine is making at 6 and 8 meters per second. We have our noise level is 81 decibel. Where if you take the big bonus you heard, their noise level is 105. And every time you lower the noise by 3 decibel, you half it. You cut it in half. I don't know the exact expression, but I know that Siemens and Vestas, they have been working for many years to try to reduce their noise by only 1 decibel. We had the first machine we made and measured on was 87.4 decibel in noise level. And the newest one we have now is 80.8. So we say it's 81 decibel.
They measured that 1 meter away from the...
Yeah, they calculated it 1 meter because they measure it on a hard plate on the ground with a microphone on in the total height, the same distance as the total height of the machine.
Right.
Then they measure this. They have to measure between 5.5 and 8.5 meters per second, because we need to prove how it is at 6 and 8 meters per second. So that means how much noise it makes on more than 10 meters per second, it doesn't matter. But
do they measure it in different orientations? Because I'm sure it throws the noise in certain...
No, they measure it backwards, as behind the rotor.
Oh, downwards.
Yeah, downwards. Yeah. Because they say that noise spreads circular, no matter how things are. But you feel it in another way, because when you stand behind it, you are almost always near trees or buildings, or you have another way to feel it or to hear it than if you're standing in front of it, because then you have the wind before the wind turbine has.
Right.
But if you measure it, that the noise is coming circular. It doesn't matter where you are, but they say you have to measure it behind anyway. So, but we made this measurement, and now we have a report which says what the background noise is by our wind turbine. So that's quite funny that you have to make a type approval where you only use somebody else's noise, not our own. But we have some problem with some of the authorities that they can't understand this. Our neighbor municipality here on Mors, she said you can't approve this because we can't prove what the noise is. I said, but you can go and hear it. And most other municipalities say that it's no problem, because when we can see that the noise is so low, there will never be any problems then. So we make an approval anyway for building an application. No problems. But it is made. The machine is produced here at Grønkjærs Maskinværksted, and it's a combination we can say we have sub-suppliers in this area. That's why we call it the THYMøllen. This area is Thy. And we have the metal parts here. They are cut, laser cut, and bent at a company in Herdom that's called KK Metal. And then they're taking them here and welding all together, sending it for galvanizing, hot dip galvanized. That's the best thing you can do because the air is there's big humidity and there's a lot of salt in the air here near the coastline. So it's very aggressive. We have main shaft, brake disc is produced also here at Grønkjær Maskinværksted. And we make the controller ourselves also, the electrical part, and put all together for the controller box. This is also, we have our own electrician who is doing this. So we're trying to do as much as possible here in the local area to create working places and create values here for our local society. Because we see a lot of things is coming here from China and from England and from Ireland. And most of the machines that comes from these areas, they're much smaller than this one, much lighter. But they're not built to work under the conditions they are here in this area. Because the law here says that we cannot put up these machines more than 25 meters from buildings. And that means if you put up 25 meters from building, you have the buildings, you have trees. That means you have lots of turbulent winds. So you have wind gusts that is shaking it all the time, and there's a lot of wear on it that way. So that's the reason that we're using. It's an 18 kilowatt gearbox for 6 kilowatt wind turbine. It's a 7.5 kilowatt generator that we are just stamping down to 6 kilowatt because 6 kilowatt is the limit that you can use for this legislation we have here, where we can run the meter backwards. You have it in some states in America and in Canada also. You have net metering, as they call it, where you put the electricity in the net bank, to say popular, and then you just take it back when you need it. If the wind turbine is producing more than you need in your household, then you save it up on the grid. Then the grid company is selling it. And when it's no wind and freezing, then you just take it back. Your meter is just read. You take like a balance once a year with the grid company, and then you find out if you have to pay money to them, or you get a little money back. It's a very good way to do it because here in Denmark we pay 2 crowns per kilowatt hour for private persons. That's quite a lot. In Norway they only pay 1 crown. We have lots of tax on this. So, and if there's anything Danish likes to do is save tax. So if they can buy a wind turbine and save 2 crowns per kilowatt hour, then 1.35 is tax out of this. So if you produce 15,000 kilowatt hours on this wind turbine and you have ground heating or a heating pump system in your house to make your heating and normal electricity for your electrical things, then you can pay back this wind turbine on less than 10 years on an investment on 360,000 Danish crowns. So that has made it very, very popular.
That's an installed price?
That's installed price, including VAT. Here in Jutland. On Zealand it's 20,000 more expensive because we have lots of transport. But also they pay 2.5 crowns per kilowatt hour, so they get still a better business. So it doesn't matter. But it's made to the first 3 wind power machine that was made in 83. There's one not so far away from here in Plough that has been operating since 84 with wooden blades, still operating. Wow. We have one that we took down to put up the prototype from this one. It was an 11 kilowatt, the same design as this. It has been running from 85 without, the only repair that was on this machine was 2 brake calipers that was replaced 3 years ago. So it's a very solid machine and very reliable also. And it is necessary to have that kind of machine because when you pay so much money for it and you're depending on your economy then it's good to have one you know you don't have to repair all the time. So, any questions? You want to hear something about the techniques, how it is? Or?
I missed a little bit because.
Okay.
Did you explain that many of the components are locally made and?
Yes.
Yeah.
I'll tell you a little about how it works if you want to know that. If you don't know it, if you know how a wind turbine works, you can see it. It's no problem. But if you don't know, I can tell you how it works. You'd like to know that? Okay.
Yeah.
You know, we put the rotor. I don't think we have any blades here. We put a hub on here and 3 blades, and the rotor diameter is 7.13 meter, which gives 40 square meter surface on the rotor. And then it's put here on the main shaft, which is on 2 big bearings, and we have a brake disc here with 2 brake calibers, and those brake calibers are made as negative working. They are very powerful springs here that is pressing the brakes together. So if there's no electricity on the machine, it will never be able to work. We have to have power on the hydraulics to press the brake pads away from the disc. This way it is fail-safe.
Right.
Because if the grid is dropping out, if there's a hose that is cut, it'll stop the machine immediately. And
those springs are strong enough even in very strong winds.
yes, they are. 1 caliber alone can stop it. We have 2 to make extra sure. And another thing is that on the blade tips, the outer 40 centimeters of the blades is on a shaft that turns. It's a very simple way, and it's the weight of the tip that takes it out if it goes up in speed. So then the tip just turns out 90 degrees and prevents it from running faster than 115 RPM. So this way it'll be running, but it'll not run away. That's the worst thing that can happen because if it's going quicker and quicker, faster and faster, then the blades will start doing like this, and then eventually they will hit the tower and it'll crash. So we made a triple safe system on this machine, because when it has to, if you can place it only 25 meters from your sleeping room, from your bedroom, it's not funny to think that what can go wrong. It's not quite sure you will sleep so well if you have a hurricane. And also we have it made so that if we have more than 25 meters per second for 1 minute average, then it stops also. Because again, when you have all this hurricane wind or very hard storm, there's so many gusts in the wind that if something happens, you never know where it ends up. So it's better that just to stop it, because in this country we have maximum 10 hours per year with more than 25 meters per second wind. So that means you can only lose 60 kilowatt hours on a year by stopping. And then it'll last much longer this way, because if it's running in these conditions, it'll be very hard on blades and bearings and your system. Everything will be worn much more that way. When it turns the shaft, it goes in the gearbox here, where it's transformed up to, it's a ratio 1:8, so 1 RPM here is 8 RPM there, which means we have a 750 RPM generator. And what it does, it's a normal 3-phase generator. It's not like most of the others wind turbines who's making, what do we call it? It's a DC. This one is making AC. So it's going like this. So we go directly on the grid. We don't need any converter or inverter or anything. And the grid company is very happy about that, because they say these inverters, they make harmonic distortion. And that makes a lot of trouble with TVs and computers.
How is the speed regulated then?
It's not regulated. It's fixed by the grid, the 50 hertz on the grid.
No, the grid is at 50, so you have to make sure that this is at 50, which means you have to make sure that this is at 50 divided by 8.
So it goes the way that it starts when the wind comes in. It's accelerating. Then we have a measurement. We have a what do you call it? Sensor on the generator and one here on the main shaft. Then it counts the RPMs, and when it comes to 10 RPM below nominal speed, it slowly, softly cuts in the motor, the generator. We have a soft starter.
Is it clutch?
No, it's just electronically.
Oh, electronically.
Yeah. So it goes. It's like you turn. Not like you have a switch. When you have a soft starter, then it makes sure you don't cut in with a big. What do we call it?
Spike.
Yeah. Exactly. A spike. So this way we go very soft on the grid, so we don't have any bulbs blinking or anything. And it's also much better for gearbox and wear bearings when you go smooth on the grid that way. And what is happening then is that the wind will try to turn it over the nominal speed, so then it starts producing electricity. So what we make is braking force we are using to produce electricity. So the more wind, the more it will try to brake to stop, keep it down on the same speed, and that makes more electricity. So it's the opposite of a motor.
That's strong enough to regulate it.
Yeah.
That's very pretty.
This has been used for 30 years now in Denmark. It works fine. So you can see on the top of the cover we have a wind meter, anemometer, and a wind vane, which is connected to the computer, so it knows where it is. It tells it how to regulate in the wind all the time. And there's a yaw motor here that turns it on this big wheel over there, gear wheel for the yaw system. And if you see the one over there, you can see how it is mounted up. You can see one glass fiber pad here. There's three of these that is standing on this wheel. And that means that instead of you have some producers are putting this on a big roller bearing. But when you put it on a roller bearing, it'll start doing like this when the wind is a little gusty. So we do it instead. We use the weight of this on these pads. So it stands on this with a bolt in the middle. So then you're using the forces in the weight in the nasal itself to keep it steady. It's much easier, much cheaper to do it that way, and much simpler. You don't have a big bearing you have to replace from time to time. You just replace these after 15 years or so.
This is skill.
So you see this is the kingpin that is down here, and we have some bushing here. This is regulating it. So it's throwing around like a trailer. Any questions?
How much does the whole thing weigh?
It weighs, the nasal weighs 800 kilos.
800 kilos?
Yes, and the tower, we have a largest tower that is 21 meter high and it weighs 2 tons.
Wow.
1,000 kilos.
Is that the minimum height, 21 meter?
That's the maximum. Yeah, we cannot make them more than 25 meters. That's the maximum height we can use. And 25 meters away from the house, and 25 kilowatts. That's the maximum. Also, 3 times 25 is
Like that number?
yeah, apparently.
What other blades
I missed a little bit right behind him.
What?
Right behind here.
Yeah.
That motor right there is
Yeah.
just for the
It's just for the hydraulic pressure. Yeah.
This one? This
So
one?
it's very rare. It's running. It's only maybe 10 seconds or so, and then it's stopping because there's a hydraulic. Yeah. On the other side. And then we have a magnet valve to keep the pressure up. So that means that if the electricity goes out, it presses the magnet valve automatically. Takes out all the pressure.
These are all your ideas. This is your design.
It is part of my design. Yes.
Do you have other engineering partners?
Yeah, we have 3 partners in the company.
Oh, okay.
The others, they are the engineers and the salesmen.
Really?
But we have been working with this for more than 25 years now, wind turbines. So also I have a company where I'm taking down second-hand wind turbines, big wind turbines.
I remember that.
Yeah.
Yeah.
So I'm repairing those and And we have some sent to Canada right now. Yeah, we just sold 2 vessels 225 to Canada. And 2 to Ireland also.
Oh, it's a large one.
Yeah, it is.
How often do these need to be serviced?
Once every second year.
Every other year? That's just greasing the bearings and
Yeah.
checking the caliber?
Yes. First time we go after 1 year because we have to retighten the bolts to torque them to make sure everything is as it. And then every 2 years from that. And every 4 years we replace the oil. Change the oil.
Every 4 years?
Yeah. Because we use fully synthetic oil.
That's not,
What?
Vegetable based?
No, it's mineral.
is that, the big ones, they don't normally use synthetic, full synthetic?
Yes, they do that also, the big ones. But they only replace oil every 5 years or so. They take oil samples. We could do that, but I think if you take an oil sample, that costs about 1,000 crowns.
Yeah.
And 3 liters of oil costs 500 crowns.
Really?
So what's the problem? Just have it, get it out and have it clean.
Yeah.
I think that's better.
Wow.
So
Where are the blades produced?
they are produced. We started to produce as wooden blades here locally at a stairway factory. They had a CNC that they could make the blade. Yeah.
That's awesome.
But we had a lot of discussion about this because in my opinion a wooden blade is very good because you have a more heavy blade than a glass fiber blade, and the structure in the wood is better when it's massive. You have absolutely no noise in the wood. There's no noise from bearings or anything. If you have a glass fiber blade, you have like a violin.
Yeah.
If you knock on it, it sings.
Mm.
There's a lot of vibrations in there. So now we have made a new glass fiber blade, which is designed specially exactly the same profile as the wooden blade we have. And then we have put in some foam blocks in it to stop the vibrations. It works perfect. There's absolutely no noise from them.
Where are they produced?
They're made in horses at a company called Olsen Blades. Or Olsen Boats. They're also making canoes. So, but we had this made because our competitors, they always told our customers that you have to make sure you have some good oil for the blades for this machine because. And also you had to make sure you couldn't get the woodpeckers in them. So,
Yeah.
so we said, okay, if that's the problem, we'll make glass fiber blades also. Then you can choose between wooden blades and glass fiber blades.
You give them a choice.
Yeah, we give them the choice. But the glass fiber blade is approximately 10,000 more expensive than the wooden blades. But then there's no maintenance on them. They'll last for 25 years, where the wooden blades maybe have to be repainted for after 15 years or so. But we make it the way we have a refurbished set in stock. So if people are calling and say we'd like to have them refurbished, we come out with this, take one down and take the others up, and then they're running again in 1 hour. And then we take the old set back home and refurbish them, and then they get the invoice on that piece of work. So that way it's minimizing the price for it.
Mm.
You have to be very logistic in this way because when it's a small wind turbine, people are not earning much money. You have to keep the cost down and make everything as easy as possible. We made a special crane that we can mount on it with a hoist in. We just put on a battery on the car. So when we can replace the gearbox and generators and everything with this, we just pull it out on the side and can lower it slowly down with this electrical hoist. It works fine. And you save 1,500 crowns per hour for a crane. It doesn't matter, maybe it takes half an hour extra to put this together and take it down. It's made in aluminium, so you can easily take it off.
How many people work here?
There's 3 here.
The 3 partners?
Yeah.
You do everything?
No, we have the 3 employed here.
Okay.
And then I'm the manager of the company and selling also, doing some bookkeeping. My wife is doing some of the bookkeeping, and we have a salesman, one of my former colleagues from back when I was at Micron. So what we really want to make sure is that we don't have anybody in the company that doesn't know anything about wind. We want to make sure that the people who is our face to our customers know everything about wind. Because lots of our competitors in this market, they're all salesmen, but not technicians, and they haven't ever been in the wind business before. So when we come out, we do like this, but we know before we get there what the wind turbine will make, because we have lots of reference wind turbines in the area. We just go into the statistics and see what is the nearest wind turbine producing and what has it been producing for the last 10 years. And then we can just recalculate this to ours. So we can, within 10%, we can predict what it will be producing every year. That's very important, because we hear a lot of histories about some of our competitors that is promising people 15 to 18,000 kilowatt hours, and the first half year it has been producing it has only been making 3. And you really have a long term on paying it back.
We call them snake oil salesmen.
Oh, okay. Yeah. That's good.
They sell you something and then leave.
Yeah, it's like the Chinese.
That's good, so all your technicians
Yeah.
can really be salesmen. They can kind of, maybe not sell, but put a good spin on your company.
Yeah, they're good heavy talker, speed talkers. What do we call them? Oh, we want to make sure that our people are satisfied with what they buy, and that's the best. Also, the best
Marketing.
Yeah, the best marketing you can have is a happy customer. And that's also why all our production from the different machines, if our customers will let us, then we publish this on our homepage, so everybody can go in and see this. There's a map. There's the wind turbine. You can click on this and see what has this wind turbine been producing today. How's the wind here in different parts of the country? Because that helps also to sell the wind turbine. If they live near this wind turbine, then they can go and see how it is compared to their own place. That gives you a much better reliability also when you come and tell them that you think you'll be producing this, because you know that the neighbor's machine has been producing so much.
And that's online now? You can go in there and...
So we have very many visitors on our homepage, several thousand each month. So it's quite funny. We had an open house arrangement in North Jutland 2 months ago. The only advertisement we made was on our homepage. There was 200 people on Sunday afternoon. So that showed us that it really was a lot of traffic on it. People came from Kunen, from Odense. Was driving 200 kilometers to come to see a wind turbine.
Wow.
Then it's really talking serious business. So. But our plan is that right now we've been producing approximately two machines each week. But the setup is, because we have sub-suppliers, that we can very rapidly rise the production and also slow down again, without costing a lot of people their work, because then we can go out and take an extra sub-supplier in to do blades or to do the machine houses and different things. So this way, that's what I learned from Bonus. That is, max 20% you produce yourself, and 80% at the sub-suppliers, because that makes you much less vulnerable if you have bad times, and it's easier to cover up with good times, to speed up. And we install them ourselves. We have our own truck with crane and everything. So it's my partners themselves that's going out. They want to make sure that every bolt is fastened the right torque. So. I think that's about what I could tell about it.
Thank you.
Yeah, thank you.
Excellent. Excellent.
Shaft, gearbox, made in England, 130 years or something like that.
So we're done yet.